Now in V2.1 we're going to look at how we can go from the data, sketch the data up, through to thinking about the positive correlation that's involved, and then using the calculator to prepare the screen plot and make your correlation coefficient. Now firstly, when we plot, you can see I've ruled up the axis and I've scaled it correctly, and then we put the points in as we go. Correlation, well, clearly there's a positive correlation. As to the actual value, we're going to have to find that using our calculator. I think it could be a weak positive correlation. In other words, there's some evidence to say that as you put in more hours of study, you'll get a better result. Now, I'll work that through on the calculator in a moment. So, entering the values as ordered pairs, 562, 395, through to 330, we can then run the linear regression. So, calc, regression, linear regression. I like copying the formula. Later on we'll find out what the residual is about. And then OK, you can see here, if I wanted to record the graph, y is equal to 4.98 plus 39.84. My R figure, 0.5085. And that confirms my original hunch there that the linear regression is shows a weak positive correlation, 0.5085. Now just going back to the graph there, okay that, and you can see the graph appearing in the line, it's a few points above, a few points below. If you want to resize that to get a better picture of the graph, I'll swap back to the data there. Now when we draw a conclusion based on the correlation coefficient, we then put the weak positive correlation with respect to some evidence or maybe a little evidence to show that the greater the hours of study, the better test result. So it's a little evidence. So the hours of study increases, so does the test